Welcome back. Here's a pretty difficult problem to do with coefficient of dynamic friction. So friction is the force that acts between two surfaces as they move against each other, in this case the skate and the ice. And dynamic, we need to know about dynamic friction and static friction. Static as in the friction between two surfaces when they are not moving, so maybe to stop a block of wood sliding down a slope, that would be static friction. We are going to look at dynamic friction. Here is the problem. A box of mass 40 kilograms is pushed at a constant speed along the surface by a force of 250, and it's not perfectly horizontal, that force. The force is applied at 40 degrees to the horizontal. Question is, what is the coefficient of dynamic friction, which is mu d, if you go by the IB data booklet, between the surface and the box? So you've got a little bit of trigonometry to do and a little bit of algebra in order to solve this. So pause the video, see if you can have a go at the problem, and then I'll go through the solution. Or just carry on watching. Let's see what happens. So we've got the angle 40 degrees here. Let's do a little bit of drawing. So first of all, the easiest way to solve most forces problems is number one, come up with the free body force diagram. Now, where does this Fx come from? Because there isn't actually a force that's acting in that direction. Well, that's a component of the push, the 250 newtons. And because we have this 40 degrees here, we can use trigonometry to resolve the 250 and get the horizontal component. So step one, draw yourself a free body force diagram. Step two, write an expression which represents the forces involved. After that, it becomes an algebra problem, but at least we know the relationship between the forces. So the force of dynamic friction is mu d r, and that's equal to the component of 250. So because we've got the hypotenuse and the adjacent is the side we're interested in, it'd be 250 multiplied by cos 40. Now, the next problem is we've also got a downwards component, and that's important for helping us figure out the reaction force because there's two forces acting down here. It's not very clear. Not only will we have the weight, W equals mg here, we'll also have the component of the 250 newtons, which acts down the way. So the reaction force to both the weight and this push will be equal to R. So therefore, there's our weight and our Fy, the sum of both of the forces acting down the way, which the surface is going to react against. If you're struggling to understand that part there, think of just pushing down on the box straight down here. The forces acting down would be the weight plus the push, okay? So that would be equal to the reaction force. The table under Newton's third would supply a reaction force equal but in the opposite direction. And we need that R to figure out the coefficient of dynamic friction. Working through the math gives us this. And because we're looking for the mu, okay, this coefficient of dynamic friction here, we rearrange this, and this gives us our final answer of 0.35. There we go.